to be sure that you follow this particular format. The first thing you need is to identify the acid. The second thing you need is identify the base. And the acid becomes the conjugate base, which I'm abbreviating as C base. Okay, the C base. Which one is going to be the C base? Well, it's the HF without the H, which is okay, and the base becomes the conjugate acid. So this guy is the base. Okay, so this guy, who is the base, becomes the conjugate acid because it takes the hydrogen from the hydrogen fluoride or the hydrofluoric acid and makes it into a conjugate acid. After that, we need to draw the line. So the acid is going to become what? The C acid or the C base? Huh? C base. All right. So C base is over here. And we need to connect those. So the base becomes the C acid, and so on the other side, it looks like that. So for your problems, what you're doing now for the do now, these problems here, I just copied them over, you're going to be doing what you just saw me do. Go ahead. There you go. You just have to close All right, good. That's your acid. Now you're getting the hang of it. Yeah, get it. Keep going. You're at home watching this? Okay, there's your C base. No, that's not your C base. Okay, the C base. The C base is the acid after it loses the proton. Go ahead, let's get those C base and C acid in the right places. You want to move it here? Yeah. Okay, we'll move this over here. Is that what you want? Okay. That's it. There you go. Okay. Now it's time to draw lines. Okay, the acid is going to become the C base. So draw the lines the way you see me doing them up there. Ah, there you go. Okay, and now the base is going to become the conjugate acid. There you go. All right? Okay, the question is, how did I know the water was the conjugate acid and not the Na? Okay, the acid, okay, let's get an arrow. Okay, the acid is the guy with the H out front.
Yes.
Right? Now, when this guy loses the hydrogen, he is going to become the C base.
Right.
So it's NO3. NO3 has to be the C base. See? Now, this guy, this part of the sodium hydroxide, the hydroxide ion is the base. Okay? When the base gets the proton from, or when the base gets the proton from the nitric acid, you've got to write what that is. And that is H2O. Now, does it make sense? All right, I'm glad you asked the question. Okay, let's go. Let's do this one now. Let's put it down a little bit so you can reach it. There you go. Okay, good, go for it. First of all, label the acids and the base. Acid and base. Okay, good. That's your acid. Again, the acid does not have to be the first substance. That's it. You get that? Okay, now, the acid, when it loses the proton, is the base. C base, I'm sorry. So, let's put the C base label on. Okay. Is that the chlorine without its hydrogen? Excuse me. Here. There's your acid, right? The acid hydrogen, the hydrogen from the acid, goes over to this guy. That's what's happening. So, when he loses that hydrogen, what is the C base going to be? This guy. This is the hydrogen. What's left? Look at it. What's left? Yeah, there you go. Okay. Now, the C acid is easy. Okay, go ahead and draw your lines. Okay, remember the acid's going to become a base, and the base is going to become an acid. Good. That's what it should look like. So your most difficult ionization is the guy that has 3 protons. And phosphoric acid is a good example of that. With this guy, you've got to go 3 ionizations. So watch what happens. And I would like you all to write this down. And if you're watching this at home on the video, you want to write this down as well. Watch what's going on. It always reacts with water. That's how it ionizes. And it's going to be an aqueous solution. So when it reacts with water, water is going to get protons. And it's going to become positive. And so ionization means the hydrogen came from the phosphoric acid. One of them, we called it a proton, goes to the water, forms the hydronium ion, and then what's left of it, what are we going to have after we get rid of one of these hydrogens? What's left? H2. Good. So over here, we're going to have H2PO4, and we lost a positive charge. So if we lost a positive charge, what's the charge on this going to be?
Negative.
It is a 1 minus. Right. Next step, take this guy here and put him here as the beginning of our second ionization. So we got the H2PO4. What's the charge? 1 minus. And we're going to react with water again, and we're just going to take away another hydrogen. Where does the hydrogen go? Yeah, to become H3O, also known as the hydronium ion. And then we're going to have 1 less hydrogen. So we got an HPO4, and that's a 2 minus now. Because he's lost 2 positive charges. And now we take this guy, whoops, wrong, get rid of that. Now we're going to take this guy, charge and all, and he's going to be HPO4, the starting of our ionization. 1 minus plus. Thank you. Yes, 2 minus. Good, you're listening. And I didn't make the mistake because I was wanting you to find that. I just made a mistake, and I'm glad you saw it. Okay, so here's our H3O plus, and now what's it going to look like? PO4. And what's the charge?
3 minus.
Yeah, 3 minus. There you go. That's why phosphate's a 3 minus. Actually, phosphate is a 3 minus anyway, and that's how you memorize ions. Right? Yep. Now this time we're going to start with a guy that only has 2 hydrogens. And I want to show you something. Oh, let's go back just a minute. I wanted to go back because I want you to see that with each ionization, it's harder to take the hydrogen away. And to give you the relative size of arrow, how much does it want to go to the right? This guy wants to go to the right this much. Long arrow. wants to go to the left because it's an equilibrium reaction, just a teeny tiny. Okay, anyone wants to take a video, you're welcome to do that. Okay, and here it gets different. On this guy, it wants to go to the right that much, wants to go to the left that much. So it's going to be a little harder to remove that hydrogen. And here, now the arrow is long tan points to the left. The forward reaction is a little teeny tiny. Okay, so on this last ionization, it's really hard to take that hydrogen away. And the same kind of thing will exist with the sulfuric acid. So let's get rid of this again and get our sulfuric acid over here. And let's watch how this thing goes. See if you can do this before I do, just on your own paper. See if you can beat me. If anybody can beat me, you tell me when you're done. I'm just going to go ahead and do it, okay? Here we go. This one is a really wants to ionize, okay? And there's extra credit if you beat me. Okay? It just wants to go to the left a little bit. So, over on the right side, we get the H3O again. And what are we going to get instead of H2SO4? Huh? How many hydrogens will there be? HSO4, what charge? 1 minus. Yeah, because we took away 1 proton. Okay? So, now we take the HSO4. See, we're just peeling away hydrogens. Plus water. And this guy really doesn't want to go to the right. He really wants to go to the left. Okay, so he doesn't ionize very much. And the ionization, you already finished? Great. Okay. Okay, now, we got the H3O over here, and he's a plus, and what's left? And what do we call this guy? SO4 2 minus is what? Sulfate ion. Yeah, there we go. Okay, you got it. Excellent. Yeah. Now, what about the third ionization? Pardon my English. There ain't none. Okay, why is that? Because we're down to what I call the nub. Now, this guy has more hydrogens. Once you're down to the original ion that was in the sulfuric acid without any hydrogens, you've gone as far as you can go. And that's it. So, let's go to the homework. I'm gonna do these again real fast. Any of you who can beat me on any given one? The first one that beats me is going to get 2 points extra credit.
Yes, the correct answer.
This is last night's homework, for goodness sakes. Isn't this last night's homework?
Yeah, just right here, I did it. You do it here, I did.
Now I want to see it done right.
It is right.
Okay, show me. Okay, this guy,
Send it.
H2S. Okay, anyway. So, HSE, what's the charge? What's the charge?
5. 4 minus.
What minus?
4 minus.
Where do you get 4 minus? We only dropped down 1 1 minus. And then we got the H3O, 1 plus. How many hydrogens do you have? 2. Okay. So you can't have more than you have hydrogens. Paste. B. Yeah. Oh well. Here, let's stop this. Okay, again, we have 2 hydrogens. Because we have 2 hydrogens, we can only have 2 ionizations. There's no third ionization. Okay. So the next guy down is HSE.
There is no.
S. Make this look decent. Okay, HSE, and that's a 1 minus. Drops off another hydrogen with another water, and we get, whoops, no H's, Se, 2 minus. Okay, so we've got it there. And we can go on to the next one, and that's another one of the tough ones. That's going to have, how many ionizations are going to be on this guy? Yeah, 3 hydrogens. Each ionization taking a hydrogen over to water, giving you 1 less hydrogen. H2, ASO4 is the base ion. You know what the charge on that ASO4 is?
2 minus.
1. This is a 1 minus now, but what is it when it's all along? It's a 2. It's a 3 minus, yes. And then of course we get the hydronium ion. I have written this in different orders each time because I don't want you to get the idea that there's some kind of sacred order and it has to be that way. Okay, so we take the H2, ASO4, as a 1 minus, and then it's going to be the HSO4, HASO4.